Okay, so today I did go to office hours, and this was for the lecture that I missed on October 13th. So we started off by learning what a corollary was, and when I went to office hours, I assumed that it was more of an assumption. Then I was told that it's not more of an assumption, it's more a consequence. So if event A were to happen, event B happens. And that's what a corollary is. It's more of a consequence of something happening. So we also talked about we want to wanting to prove that an angle bisector at C bisects A B. So we're gonna start with we're given that AC is congruent to BC. And here's our triangle. We're gonna have two sides. This one will be equal. And we'll have a bisector. And really quick, just in case I forget, this is C, this is B, this will be A. And we'll have a bisector that creates another midpoint, D. So we want to prove that angle alpha is congruent to angle beta. And then we'll have this be angle alpha. And then we'll have this be angle beta. Okay, so we're going to be starting when we bisect angle C, or point C. That'll be our first step. Bisect B. This will create two angles right here. We'll have angle 1 and angle 2. So I'm just going to label that. And because of the bisector, we know that by construction, angle 1 will be congruent to angle 2. So now we know that when we bisected CD, this counts as another side because we really just created two triangles. So we can say that side CD is congruent to side CD. So it's congruent to itself by the reflexive property. And the reflexive property just means that something is congruent to itself. This will be our fourth step. So now we have triangle ADC, ADC, and triangle EDC. We know that we can pass side angle side. We have that AC is already congruent to BC. That's one of our sides. So I'm just going to write this in blue. AC is congruent to BC. We know by construction of a bisector that angle 1 is congruent to angle 2. And then we know that CD, which is the side that made two triangles, is already congruent to itself by the reflexive property. So this is what proves that SAS is true. And since we passed SAS, we know that the triangles are congruent. So now we know that triangle ABC is congruent to triangle BDC. And that gives us that angle alpha is congruent to angle beta by corresponding parts of It's by CPCTC, which does stand for corresponding parts of congruent triangles are congruent. So since we know that triangle ADC is congruent to triangle BDC, we know that all the other parts of those triangles are congruent. So that proves that angle alpha is congruent to angle beta.